So there's a compound interest formula given to us over here, and we're going to use that formula to find account balance in various compounding situations, okay? So N refers to the number of compounding period you have in a year. So if it's quarterly, you have to think, how many quarters do we have in a year? Well, there are 4 quarters in a year. So for quarterly, you will be plugging in N equals 4, okay? What about if it's daily? How many days do you have in a year? Well, there are 365 days in a year. So for daily, you will do N equals 365. Okay? Now, for monthly, well, you will need 12 because there are 12 months in a year. But what about annually? Okay? How many years do you have in a year? Okay? Kind of silly question, right? You just have 1 year in a year. So for these compounding situations, you will have to identify what N is, but everything else will be given to us in this example. So let's see. Compound interest future value. Luis invest $5,000. So look at that. They are giving us that the principal is 5,000. And this is an account that earns an interest at an annual rate. So see what they're giving us is the annual rate. So if you want to find quarterly or weekly or monthly, it makes sense to divide that annual rate by how many of these compounding periods you have in a year. So one thing that you will want to do is convert this into a decimal by dividing by 100. So 3.25% is 0.0325 in decimal. And they want us to find the future value after 5 years. So t is equal to 5. Time is equal to 5. So let me set up all 4 of these, and then I will open up a calculator and do all of them at the same time. Okay? So for annually, well, Luis starts with 5,000. Okay, we'll write down 5,000. That's getting multiplied by 1 plus the APR of 0.0325. Well, you're dividing this by 1. Okay? But here, it really doesn't make a difference, right? You don't really have to, but I'll just keep it so that I can show you the consistency, okay? So that's what you will have to type in, okay? The annual rate divided by 1 year, but we're raising that to 1 times 5 years because we are looking at 5-year investment, okay? If it was like 10-year investment, I would have multiplied by 10. But that's what you will have to type in for the first answer. Let me do the quarterly now, okay? For quarterly, you also start with $5,000, but inside the parenthesis will be a little bit different. First, you divide that APR by 4 to convert it into quarterly rate. And this growth factor will be multiplied by itself how many times? Well, there are 4 quarters in a year, and we're looking at 5-year investment. So we're looking at really 4 times 5, 20 quarters. Okay, so the exponent has to be 20 in that case. Okay, we'll get the answer later. Now let's do the monthly. Well, for monthly, we start off the same with the $5,000. But we are going to be adding the 1 plus the annual rate divided by 12 to convert it into monthly rate. And the exponent has to be how many months we have in a 5-year period. That will be 12 times 5. Okay? Just writing these down. All right, last one. What about for daily? Well, we start with $5,000, same situation. But we are going to be dividing that APR by how many days we got in a year. And this is us converting it into daily rate. Now, how many days do you have in 5-year period? You can do 365 times 5, and that will be your exponent, okay? So let's get 4 answers now. Okay, and we'll get to my calculator. I'll delete all these. I was doing another problem. Okay, so first one, 5,000 times 1 plus 0.0325 divided by 1. I know, raised to the 1 times 5th power. So that's the answer for the first part. And look, I'm going to copy it. Just change the denominator to 4 and 4. So that's the second answer. The third case was what? Weekly, right? So monthly. So I changed that number to 12 And the last one was daily, so I changed that number to 365. 365. So let me write all these answers down, okay? So the first answer, and you guys, it's very important that you test out your scientific calculator before the test day, because even if you know how to set these up, if you don't know how to type these into your calculator, you will be in trouble, okay? So $5,867.06. It's going to be the answer for part A. Next, this one right here. $5,878.38. See, do you see how the numbers are increasing, right? So the more frequent the compounding period is, the faster the money will grow for you. So here, the next answer, that's gonna be for 12 months, and that's a little more than quarterly compounding, right? $5,880, and I'm gonna have to round that up to 95 cents. And the last answer is going to be this one. $5,882, and I'm gonna have to give them 20 cents there, okay? But you can see, as n increases, as the number of compounding period per year increases, the amount, the ending balance is getting bigger and bigger and bigger, right? Okay. Find the future value of Louise's account after 30 months. Oh, 30 months. If interest is compounded monthly. So, I'm going to be using that same red equation, okay? So we're multiplying Louise's $5,000 by 1 plus the rate getting divided by 12, converting into a monthly rate. But the exponent has to be how many months we are doing, right? We are doing this investment. See, for this one, when they said just, oh, it's a 5-year period, we did 12 times 5 and got 60 to be the exponent. But when they say 30-month investment, I don't really have to come up with like how many year is that. Instead, just put 30 there, because that exponent represents like how many months we have in this investment period. So I don't know, this one could be tricky, but the reason we did 12 times 5 was to figure out how many months we have in 5-year period. If they just give you, hey, 30 months, then you use 30 as your exponent. So I'm just going to change this number to 30 over here. Oh, that has to be an exponent. And the answer comes out to be $5,422.61. You see, compared to what, 6-year or 5-year period, we just waited 30 months, right? That's less, right? So we didn't make as much money, but that is how you can do this problem when they give you number of months instead of number of years.